Hello and welcome everybody to the second video in my series of building an autonomous household rover. So in the last video we met BeeBoop, and BeeBoop, he couldn't do very much, so he could kind of spin around in a circle, and eventually we got him to be able to take some commands from my laptop and be able to drive around the place. So we made some progress on BeeBoop since then, and yeah, we're gonna talk about it now. So let's jump straight in. One of the issues that BeeBoop was having was his power supply system. So that was one of the first tasks I had to do here, was to basically rebuild that. So up to now he was being powered just by 4 AA batteries, which gives you just about 6 volts, which is about enough to be able to power an Arduino through its VIN pin going through the voltage regulator. So there's a little bit of a drop down there, which it's able to then regulate down to 5 volts, which is perfectly enough to power the Arduino. And it was also about enough to power the motors. But where we ran into some issues was with powering the Raspberry Pi. So previously the Raspberry Pi was powered more or less directly from the Arduino, and it just couldn't provide enough current to drive it. So it seems like you would think that it shouldn't take a lot of power to power Raspberry Pi, but they run on 5 volts, but the ratings usually usually need a power supply that's capable of 5 volts and 2 amps as well, which feels like a lot of overkill, but yeah, apparently they do need that. Maybe not quite as much, but they do need a decent amount of power. The other problem with using AA batteries is that their voltage drop-off curve is kind of linear. Well, I don't know if it's quite linear, but essentially as the batteries run out of juice, the voltage drops. So if you run them enough, say if you were just powering a motor off it, plain old DC motor off of it, you'd notice that as the battery ran down, the motor would run slower and slower. Of course, that's not ideal when you're dealing with digital electronics, which once that 5 volts starts dropping lower and lower and lower, the devices just aren't going to work at all anymore. So that's not ideal. You'd rather the situation, which is what I replace it with, which is a LiPo battery. So for LiPo batteries, they've got kind of a very flat voltage level, and then suddenly there's kind of quite a sharp drop off in voltage. So that during kind of the depth that you can draw from the battery, there still has a consistent enough voltage, so things should still work until the battery reaches a point where it just won't work anymore and the voltage drops off quite sharply. Using a LiPo battery, though, you should also use a little battery voltage alarm system so that you don't draw too much from the battery and don't drive it way too low in voltage, which then makes it quite dangerous when you try and charge it up again. And most commercial chargers won't even let you charge a battery that's been discharged too much. So that's what I did here. Changed the battery system out, added in a LiPo battery, and all the required switching and stuff like that. One thing to note here is, though, I'm actually just using a really simple 5 volt regulator, but I actually did have to go out and replace this in the end with a more robust DC buck converter, which has stepped down the 7.4 volts from the LiPo to 5 volts. And the issue was actually just due to current again. So the Raspberry Pi wasn't able to draw enough current from the little voltage regulator, which I think is only rated at about 800 milliamps or so. And it kept resetting itself, which was quite confusing when you're debugging, that all of a sudden it just stops working and then starts working again as the Raspberry Pi reboots. So yeah, I had to replace that with a bigger, chunkier DC buck converter, which was able to handle the current. So with that done now, he's in a hell of a lot better state. Okay, so BeeBoop's had some upgrades. He's got new power system installed, the little LiPo battery, and got a new power distribution board and everything, which just makes the whole power system more stable, which is obviously ideal. The Pi was having some trouble booting with the power, the way it was coming through the Arduino and from the AA batteries wasn't really enough juice for the whole thing, so it's a lot better now. So it's time to test out the first iteration of BeeBoop's brain. So I've done the necessary config so that I have high-level software written on the Pi, which will now, as soon as the power turns on, the Pi will boot up, and then as part of the boot procedure, it'll set up this service that's going to run in the background, and that will basically interface with the Arduino and do all the stuff that it's supposed to do. So for the very first iteration of this, it's a really dumb brain system to avoid obstacles. So what he's going to do is continuously read the position from the sensor. As he approaches an obstacle, he's going to figure out has he reached a minimum distance or a maximum distance from an object that he's allowed. If he detects that he's gone beyond that limit, then he'll randomly go either left or right for an amount of time, continually polling the sensor until that distance is exceeded, and then he'll go forward again. So it's pretty dumb. it's not very foolproof. It's probably going to get caught up everywhere, but that's the basic brain for his first iteration of avoiding obstacles. So yeah, let's try it out, see what happens. As I predicted, the first iteration of BeeBoop's brain wasn't really up to scratch, so it would crash a lot, and yeah, didn't really do a great job of avoiding obstacles. One of the big problems was that as it would get close to an obstacle, it would hit that threshold limit of where it would think that it needs to start turning. It would start turning, but then what would happen is literally as soon as it went over the threshold again, or under the threshold again, whichever way you look at it, he would start driving forward again at full speed almost immediately, which would mean that he'd then very quickly break the threshold and have to start turning again. So it was this kind of really iterative, small little turns, which would mean that it was very difficult for him to actually end up with a clear path to just get a good run at going again. So with a few tweaks, BeeBoop is performing a hell of a lot better. So one of the first things that I did was I reduced the latency in the communication between the Arduino and the Raspberry Pi. There was a small bit of a delay in there that was causing basically BeeBoop not to be able to react in enough time when it approached certain objects at speed. On the topic of speed, one of the other changes to make was to basically add sort of a linear gradient to the speed that he's traveling depending on how far away from something he is. So as he gets closer to an object, he actually starts to slow down now, which very much improves his ability to stop in time so that he doesn't crash into an object. The final thing that I did was basically to add a small delay when he starts a turning maneuver, which basically allows him to move through a little bit more of an angle before he detects if he's got a clear path in front of him, and on average that seems to give him more time to turn around before he takes off again going forwards, which appears to have given him a little bit better, at least in these tests anyway. Despite these improvements, he still has a long way to go, so he still sometimes will end up getting caught up on things, and also the way that it just kind of spins around based on a time delay isn't ideal. One of his biggest problems is that BeeBoop doesn't really know what direction he's facing at all, so as he rotates he doesn't know through how much of an angle he's turned, which means that there's no real way for him to map a space out, because he can detect the distance to an object, but if he has no idea what direction he's pointing, he can't sort of add that together to make sort of like a polar coordinate space for an area. And he also can't sweep through an angle and try and detect what obstacles are around him and then figure out where the best way for him to go is from there. So that's probably the next thing I'm going to add to this. I have an MPU 6050 IMU lying around, so I might wire that in and see if I can use that to sort of figure out like a yaw position, so I can know what angle he's facing and hopefully be able to use that to build up some more advanced mapping and some better navigation. I think that's going to have to wait for another video though. If you're enjoying this and you'd like to learn a bit more about how BeeBoop works underneath the hood, you can find a link in the description of this video for the CAD and the code. You can also find a link to the parts list there as well. If you have any suggestions for things that I should do with BeeBoop, please leave it in the comments. Don't forget to like, subscribe, and if you'd like to help support the work that I'm doing, you can also find a link in the description to my Patreon. As always guys, thanks for watching.